Hello and welcome. Have you ever looked at a smokestack and wondered, where does all of that stuff actually go? Well, it all comes down to the wind, this invisible force that's constantly shaping our world. Today, we're going to dive into a really brilliant tool that helps us see the unseen to actually visualize the patterns of the wind. Okay, so to really get this, let's start with the problem we're trying to solve. When we see pollution, how on earth do we figure out where it's headed next? Seriously, think about it for a second. You see that plume of smoke rising into the air? Does it just drift away randomly? Is there any kind of pattern to the chaos? I mean, for anyone living nearby, that's a pretty critical question. And it turns out the answer is a big no. It's not random at all. The source material makes it super clear. It's all about the wind. The direction it's blowing and how fast it's moving, those are the two key things that decide where pollutants end up. So the logic is simple. If we can understand the wind, we can start to predict the path of pollution. And this brings us to the hero of our story today, the windrows. Now, this isn't just some pretty abstract diagram. It's an incredibly powerful tool. What it does is take a whole bunch of complex weather data, sometimes collected over months or even years, and it boils it all down into one single, easy-to-read picture that literally tells you the story of the wind at that location. So we know what it is, but, how do we actually read one of these things? Let's break it down. Think of it like a special compass, but instead of pointing north, it points you to the history of the wind. Okay, so at first glance, I know this might look a little complicated. There's a lot going on, but I promise you, it's actually really intuitive once you know the secret. It's jam-packed with info about which way the wind blows, how often it blows from that direction, and even how fast it's going. We can basically break down how to read this into 4 simple steps. We're going to look for the direction, check the frequency, read the speed, and finally, take note of when things are calm. Let's tackle them one by one. First up, direction. Now this is the most important part to get right. Each of these lines, or spokes, on the rows points to the direction the wind is coming from. So a spoke that's pointing to the west, it's telling us about wind that's blowing from the west, not towards it. That's a super important distinction. Next, have a look at the length of those spokes. They're not all the same size for a reason. This tells us about frequency. It's really simple. A longer spoke means the wind blows from that direction more often. So in this example, that long spoke from the west tells us westerly winds are way more common than winds from other directions. But wait, there's more. The diagram layers in even more data. If you look closely, you'll see each spoke is broken up into different colored or patterned sections. These little segments correspond to different wind speeds, which you can check in the key. So now, we not only know the wind comes from the west a lot, we also know how fast it was typically blowing when it did. And finally, let's look at that number right in the middle of the circle. That tells us the percentage of time when there was basically no wind at all, when conditions were calm. Here, it's 30%, which means for nearly a third of the time, the air was just still. And that's really crucial because that's when pollution can just hang around instead of getting blown away. All right, now that we can all read a windrose, let's talk about how this data actually gets used in the real world. Because this is not just some academic chart, it has a direct impact on the health and safety of our towns and cities. This quote from our source material really just hits the nail on the head. It's saying that before you even think about building a new industrial plant, you absolutely have to understand the local weather. And the windrose, it's pretty much the best tool we have for telling that story. So here's the bottom line. City planners and engineers use windroses to make some really big decisions. By figuring out the main or prevailing wind direction, they can decide to build a new factory where its emissions are most likely to blow away from neighborhoods, parks, and schools. It's all about using data to design smarter, healthier places for us to live. The whole concept of the windrose is so effective that people have actually adapted it to do more than just track the wind. Scientists can use the exact same visual idea to answer much more specific questions about our air. And this leads us to something called the pollution rose. It's a subtle but really powerful evolution. A standard wind rose answers the question, where does the wind usually come from? But a pollution rose answers, from which direction is the most pollution actually arriving? It directly links wind patterns with air quality. And you can get really specific with these. The source material talks about all sorts of custom roses. You can have one for smoke, another for sulfur dioxide, one for hydrocarbons. You can even have a precipitation rose. Each one gives planners an even more detailed picture of what's happening in the atmosphere. When you think about it, the windrows is just an amazing example of smart data visualization. It takes this huge, invisible, chaotic force and makes it simple, understandable, something we can actually use to make better decisions. It kind of leaves you wondering, doesn't it? What other complex, invisible patterns are all around us, just waiting for the right kind of picture to finally reveal their secrets?